Hello students, welcome to all of you in my YouTube channel. I am Dr. Himanshu Sarkar. In my last lecture, I had given the electric field intensity due to distributed charge problem. For example, I had already discussed how to calculate electric field intensity due to a charge distributed over a ring of radius A. Now, I will discuss another example of the uniform distribution of charge. Suppose I consider this a rod. Here this length is L, charge Q is distributed over this rod. I have to find intensity at any point P outside the rod. How to find it? I will discuss. Before that, I request to all of you to subscribe my channel so that all of my channel videos you can see it. In my last lecture, I discussed that is a ring. This plus Q charge is distributed over the ring, radius A. I have found out the intensity at point P. This distance from point P is at distance x from the center. In my last lecture, I have derived what is the formula of the electric field intensity. That is E is equal to, I told you, 1 by 4 pi epsilon naught q x by a square plus x square to the power 3 by 2. In my last lecture, I have derived it. One thing, this formula is very important formula for all of you who will appear for the JEE, NEET, etc. Now, I will discuss a similar type of problem, another problem that is charge is distributed over a rod of length L. Charge Q is distributed over the rod of length L. This is the rod. This plus Q charge is distributed here. Length of the rod is L. I have to find out the electric field intensity. Suppose at point, I have to find out electric field intensity at point P is where at distance R from one end of the rod. P is where at distance R from one end of the rod. I think clear. So how to do this problem? I told you in my previous lectures, electric field intensity, what is the formula? All you know. That is what? Q charge at distance R, intensity formula is equal to what? 1 by 4 pi epsilon naught into Q by R square. Here, in this formulation, this Q should be treated as point charge. Point charge means what? Charge confined to a very small zone. Here, this Q charge is what? That is point charge. But here, problem is different. That is a distributed charge problem. But here, we consider distributed charge, not point charge. This Q is a point charge, but here we consider distributed charge. Here in this case we consider distributed charge, not point charge. Then how to solve the problem? I will solve the problem as the previous method. That is, I will consider a very small section of length from this rod. Suppose the length is dl, and dl is so small that charge over it may be think as a point charge. Okay. So what I will do? This is a rod. I choose a small section of length. Suppose I choose a very small section of length dx. I have to find intensity at point P. This is from one end. This distance is what? R. This is a rod of length L At distance r from one end, you have to find intensity, and this point P is at distance x, from this section. Can you tell me what is the charge confined in dx? You know, over length L charge is equal to what? Q. So over length dx charge is equal to what? Q by L into dx. That is, you can write down as dq. This Q by L into dx is a very small amount of charge. We can treat it as a point charge. So what is the intensity at point P? Intensity is equal to what? dE. That is equal to what? 1 by 4 pi epsilon naught into dq by x square. Here this dq treat as a point charge. Okay. Here dq treat as a point charge. So dE is equal to what? That is 1 by 4 pi epsilon naught 1 by x square. dq is equal to what? Q by L into dx. Here we consider dq point charge as what? Q by L into dx. Already we have discussed point charge dq means q by L into dx, this dx. Okay. So now total intensity will be what? That is the D means what? Electric field intensity at point P due to the small section of length dx. So total intensity is what? How to do? We have to do integration. That is, total intensity is equal to what? That is 1 by 4 pi epsilon naught into Q by L into integration of dx by x square. Now the question arises, what is the limit of integration? This point P from here is what distance? That is r. So lower limit is r. And upper limit is what? This point. Because charge is totally distributed over this length L. So upper limit is what? R plus this length how much? You know, this length is what? That is your L, length of the rod. So R to R plus L. I think all students clear up to this, no problem. So now if we integrate, you can write down 1 by 4 pi epsilon naught q by L. What is it? That is x to the power minus 2 dx from R to R plus L. That is what? 1 by 4 pi epsilon naught q by L into x to the power minus 2 plus 1 by minus 2 plus 1 from R to R plus L. That is what? Minus 1 by 4 pi epsilon naught q by L into 1 by x to this power R plus L, this power R. That is to say, that is E is equal to, I can write down minus 1 by 4 pi epsilon naught into q by L into 1 by R plus L minus 1 by R. So ultimately we can find out the result. That is equal to 1 by 4 pi epsilon naught q by L into 1 by R minus 1 by R plus L. Now, so I can write down 1 by 4 pi epsilon naught into q by L into R plus L minus R, that this 1 by 4 pi epsilon naught into QL by QL by L into R plus L, LL cancel out. This is the intensity formula. I think all of you clear, no problem. I am stopping my class here. This is very much important for all of your competitive exam. JEE did like that. So if you have any doubt, you use my WhatsApp number. You can contact me in my WhatsApp number, which is already given in my description box. I am stopping here. Thank you.